Dear students, today let us start with the sixth module. So, in the case of sixth module, there we need to consider the economic analysis related to energy, auditing, and management. So, which are all the main topics included under economic analysis? One topic, that is cash flow model. The other one is simple payback period. Third one is average rate of return. Fourth one is time value of money. Fifth one is net present value. Sixth one is internal rate of return, and the last one is life cycle costing. So all these topics, which are all the topics which we need to consider. First one is cash flow model. Cash flow model. Second one, we need to discuss about simple payback period. Third one, we need to go through the internal rate of return. Fourth one is time value of money. Fifth one is average rate of return. Average rate of return. Sixth one is life cycle costing. The last one is net present value, NPV. Net present value methods. So these are all the topics which we need to consider. Okay. So in this, the first topic, what it is, cash flow model. What do you mean by cash flow model? In order to represent the increase or decrease in the amount of money of a person, or in case of a business, or in case of an institution has. Okay. So cash flow means the amount of cash that generated or consumed in a given time period. While we are considering a particular project, automatically related to that project, there will be some consumptions. Okay, or there will be some amount we can generate it out. So that generated amount or consumed amount, which we can consider as cash flow. Okay, financing activities. That means once we are, so what do you mean by financing activities? So in case of financing, there may be some principle of amount of activities related to non-current liabilities and owner's equity. That means non-current liabilities and owner's equity items include the principal amount of long-term debit or dividend payments. Okay, so those are coming under financing activities. So that's also coming under cash flow model. Next, we can go through the term called simple payback period. So what do you mean by simple payback period? Simple payback period means it is a time period only. So in order to represent the number of years required to recover the initial investment, considering only the net annual saving. So while we are considering a project, definitely we need to think about the initial investment. So considering that initial investment, in which year we will get it out, the total amount we are paid for buying that project. So in order to represent that, we are using the term called simple payback period. So simple payback period means simple payback period cost or SPP is equal to SPP equal to initial investment divided by yearly benefits minus yearly costs. So that is simple payback period. That means simple payback period means it is a ratio between initial investment and net annual saving. Net annual saving means while we are considering a project operating in a 1 year, then there will be some benefits. From that benefits, we need to remove that yearly cost. Okay, so by using these two, we can explain the simple payback period. Simple payback period we can explain with the help of initial investment and net annual saving. So once we are operating a project means for a particular year there will be some net annual saving. So if we are dividing the initial investment with the net annual saving, then we can find out the simple payback period. So that means simple payback period is the time period required to recover the initial investment. So up to what year which we need to wait in order to recover our initial investment. So in order to represent that, we are using the term called simple payback period. So also we can write it as SPP, simple payback period, is equal to initial investment divided by yearly benefits minus yearly costs. Yearly benefits minus yearly costs. Net annual saving means yearly benefits minus yearly costs for a particular year. For one particular year, if we are considering, means there will be yearly benefits. From that yearly benefits, if we are reducing our yearly cost, that is net annual saving. So the initial investment we are dividing with the net annual saving, then we will get that time period. That means the initial investment in which year we will get it back. So next we can go through the average rate of return. So average rate of return or ARR is the ratio between average annual profit divided by initial investment. That means the percentage rate of return expected on an investment or asset as compared to the initial investment cost. Okay, so with respect to initial investment cost, what will be the percentage rate of return expected on an investment? It does not consider the time value of money or cash flows. Next we will discuss about the topic called time value of money. Okay, so this average rate of return, it does not depend on that time value of money. So that is the point here we need to consider. That means it does not consider the time value of money. Okay, so that is the point. So it is the ratio between the average annual profit with the initial investment. Okay, so average annual profit, that is we are considering with the initial investment. So that ratio we can call it as average rate of return. So this is also coming under financial analysis. So next topic, that is we need to discuss about time value of money. Okay, so while we are considering a particular project, definitely we need to think about two costs. That means there will be some initial cost, that means related to initial investment. for capital cost. Similarly, there will be annual cost. Annual cost includes operating cost, maintenance cost, and related to the energy. We may require the energy. Okay, so if we are considering the fuel, we need to buy the fuel. So automatically that cash also we need to consider it out. So that's all are coming under annual cost. So while we are considering a project, there will be two types of cost: initial investment and the annual cost. So it's how we can explain with the help of time value of money. That means to assess project feasibility, the present and future cash flows must be equated to a common basis. That means if I have an amount of 100 rupees today, its value changes after 2 years. Okay, so that's we all knows. We are investing that 100 rupees into a bank means there will be a 10% interest if we are getting, means after 1 year what will be the amount? 100 that means 10 rupees extra value will be there after 1 year. Okay, so that is the difference. So the time value of money, so it explains the present and future cash flows. That means it equates the present and future cash flows equated to a common basis. So that common basis, how it is, that is we can explain with the help of an equation. That is next which we need to discuss. So if we are considering future value as FV, that we can equate with the net present value NPV into 1 plus I raised to n. What is net present value or NPV? That we are considering the net value. We will discuss later. Okay, so this is the equation which is relating the future value and present value. Okay, FV means future value. FV means future value. And what is NPV? NPV means net present value. Net present value. What is I? I means interest rate. And what is N? N means number of years. So the future value and present value, that we can equate it out by using this equation. Future value is equal to NPV into 1 plus I raised to n. FV means future value and NPV means net present value. I means interest rate and n is the number of years required. This we can explain with an example. This one we can explain with an example. So at present I have an amount of 100 rupees. After 1 year n will be equal to 1, and if we are considering interest rate as 10%, that means 10 by 100 is equal to 0.1. Then what will be the value after 1 year? So that is we can explain with the help of this equation. NPV is equal to 100. If this is the situation, means the future value is equal to 100 into 1 plus 0.1 raised to 1. What will be the value? 100 into 1.1, that means 110 rupees. So now if I have an amount of 100 rupees, after 1 year its value will be 110 rupees. If that bank gives an interest rate of 10%. So this is the relationship between the future value and the net present value. So the NPV calculates the present value of all the yearly cash flows, that is capital cost and net savings incurred or accrued throughout the life of a project and summates the net present value. NPV we can find out by using this equation. What it is? Cash flow for the 0th year divided by 1 plus k raised to 0. K means interest rate only. So starting time itself, that is related to the initial investment. After 1 year there will be CF1, that means cash flow related to 1 year. CF1 divided by 1 plus k raised to 1 plus etc. up to the cash flow related to nth year divided by 1 plus k raised to n. So in this, CF means cash flows and k means interest rate, or we can call it as discount rate. Okay, and 0, 1, 2, 3, that etc. up to n, that means the number of years. Depending upon the number of years, the net present value also changes. So commonly, as in the form of summation, we can represent the NPV as summation of t equal to 0 to n CFT divided by 1 plus k raised to n. So in this, CF means cash flow and k means discount rate or interest rate. Okay. So next topic, that is internal rate of return, that means IRR, internal rate of return. So this means this method calculates the rate of return that the investment is expected to yield. So what will be the rate of return required in order to that initial investment we need to expected to yield? Okay, so that is explained by internal rate of return. So internal rate of return, actually it is the interest rate. Okay, it is the interest rate for which total discounted benefits become just equal to the total discounted costs. Okay, so once the total discounted benefits that equates, that we can equate with the discounted cost, for that condition what will be the interest rate? Okay, so in order to represent that interest rate, we can use the term called internal rate of return. Okay, so once we are considering a project means, automatically there will be capital investment and related maintenance costs. Okay, so in order to nullify all those costs from that project itself, we have getting some benefits. So once the discounted benefits and the discounted costs are equal, for that what will be the interest rate? So in order to represent that, we are using the term called internal rate of return. So it is better to choose the highest rate of return type projects. If we have two projects, so one having the highest rate of return as compared to the other, then it is better to choose the highest rate of return project. So internal rate of return we can explain in another way also. That means IRR of a project is the discount rate which makes its net present value, that means NPV, equal to 0. We already having the equation for the NPV, that means NPV equal to CF0 divided by 1 plus k raised to 0 plus CF1 divided by 1 plus k raised to 1, etc. up to CFN divided by 1 plus k raised to n. So that is the equation for the NPV. So once the NPV equal to 0, so at that situation what will be the discount rate? Okay, so that is the internal rate of return. Okay, so once the net present value of a project equal to 0, so at that time what will be the discount rate? So that discount rate is actually internal rate of return. So that means this is the equation for the NPV. We already discussed it. So instead of writing the NPV, here we can write it as 0. Life cycle costing is the process of estimating how much money you will spend on an asset over the course of its whole life. So once we are implementing a project, over the whole life of that project, we need to consider the costing. That means the initial investment cost. Along with that initial investment cost, we need to think about the cost related to maintenance, repair, replacement, energy, and any other monetary costs. Are the costs related to the purchase, installation, operation, maintenance, financing, depreciation, disposal of that project? There will be costs. Okay, so those are costs, we can call it as life cycle costing. Okay, or whole life costing. So once we are considering a project, its whole lifetime period, what much cost is there? So for explaining that, we are using the term called life cycle costing. Okay, thank you.